we are now getting into module 9.5, and this is geometric sequences. And let's look at our learning target. I can identify and generate geometric sequences, and I can construct and use exponential functions for geometric sequences. All right? So our vocabulary is geometric sequence and common ratio. And then before we get into geometric sequence, we've already done arithmetic sequence in the past, okay? And so let's quickly look at the difference between the two. So we've already done arithmetic sequence, and that is a numerical pattern that increases or decreases at a constant rate, which is called the common difference. So you are basically adding, the same constant to each term in this. Now let's talk about geometric sequence. So in geometric sequence now, this is a pattern of numbers that begins with a non-zero term, and each term after it is found by multiplying the previous term by a non-zero constant, which is r. And so the common ratio is the constant used to multiply in a geometric sequence, and it is found by dividing any term by the previous term. So once again, the biggest difference, of course, both are increasing or decreasing, but what is happening over here? One is addition, the other one is multiplication. Okay, so that is the difference between arithmetic sequence and geometric sequence. So I put two questions over here, and we're trying to see if this is a geometric sequence or not. So if I were to solve this, first and foremost, I need to know that dividing a term by the previous term results in a common ratio. So if I divide a term with the previous term, it's going to tell me what the common ratio is going to be, which is my r. And to find the common ratio, divide each term by the previous term, and then you write the ratio in the simplest form. So let's look at the first one that I have. And I'm determining whether the sequence negative 432, 144, negative 48, and 16 is geometric, and we are going to see and explain if it is. So I am going to do the reverse of multiplication. Okay, so I'm going to divide to see if I do have that common ratio. So if I divide 144 by what's before it, which is negative 432, okay, and then if I put it in my simplest form, I am going to get, I know that 144 times 3 gives me 432. So this is going to be negative 1/3. All right, now let's look at the next one. Let us do negative 48 divided by 144. And I know once again that 48 times 3 gives me 144. So therefore, this is also negative 1/3. All right. If I divide 16 by negative 48, I know that 16 times 3 is going to be 48. So that is also negative 1/3. Since the ratio is the same for all of the terms, which is negative 1/3, see, this is the same ratio for all of them. This is a geometric sequence. Okay, so as you can see, the ratio is exactly the same for all of them. Let's look at the next one. Determine whether the sequence 16, 12, 8, and 4 is geometric, and then we can explain this. So let's look at this one. So we are going to divide 12 by 16, and when I divide 12 by 16, I'm going to get 3/4 in my simplest form. Okay, Then I'm going to divide 8 by 12. And when I divide 8 by 12, I get 2/3 in my simplest form. Then I'm going to divide 4 by 8 and I get 1/2 in the simplest form. Now, are the ratios the same? No, 3/4, 2/3, 1/2 are all different ratios. And so therefore, the sequence is not geometric. All right, let's look at these two now. And we're determining whether each sequence is geometric. If so, determine its common ratio. So we are going to look at here, because this is the first number is this, the second number is this, third number, fourth number, etc. So basically what are we doing? We are dividing 20 by 8. This way, we're dividing. Okay? And so this is 10/4. Right? Which is 5/2. I'm just simplifying. And so what do I get? I get 2 and 1/2 or 2 and 5/10. Okay, so this is my ratio over here. What about 50/20? So if I simplify by 10, I get same thing, 5/2, which is 2 and 5/10. So that is my common ratio. And then when I divide 125 by 50, I again end up with 2 and 5/10. Okay? So therefore, I can see that I do have a common ratio, which is 2 and 5/10. So this sequence is a geometric sequence. Yes, that's why I put the check mark. It is a geometric sequence. Let's look at the other one. So we are going to divide from here to here. So if I have 700 over -7/10, okay, I can see that this is just changing by a negative what? 1/10, right? And same thing over here. As you can see, each of the 0 is being added on. So all the common ratios it's going to have -1/10. So then see, another 0 is added on. So basically, this also is a geometric sequence. This sequence is a geometric sequence because it has a common ratio of -1/10. Okay? All right, so the next thing that we'll have when we're finding terms of geometric sequences, we are supposed to find the next 3 terms in each geometric sequence. So once again, I can look at this and I am going to first find what the common ratio is. So I am going to go ahead and divide with the previous number. So if I divide 16 by 64, okay, I'm going to get 4 times 16 is 64. So my common ratio here is 1/4. That means that's what I'm multiplying with to get 16, because 64 times 1/4 gives me 16. Then I'm going to take 4 and divide that by 16. What is 4 divided by 16? Again, I get 1/4. So you can see that my common ratio is going to be 1/4. Then if I divide 1 by 4, I'm going to get, of course, 1/4. So that's my common ratio. So as I can see, my common ratio is 1/4. So then what I'm going to do next is I am going to multiply by the common ratio. So I'm going to take from here 1 times 1/4 is going to give me 1/4. So my next number is 1/4. Okay. Then I'm going to take 1/4 and I'm again going to multiply with 1/4 and I'm going to get 1/16. So that is my next number over here. Okay, and then I'm going to take the 1/16 and I'm going to do times 1/4 and I'm going to get 1 over 64. Okay, so that is my third number on that list is 164. So these are my 3 terms that I just added on to this list. Okay, so once again, you find what the common ratio is, and then because you are multiplying each term ahead with that common ratio, that's all I'm doing. Okay, now let's do the next one where I have the table, and so I am going to divide 12 by 8 to find the common ratio. So 12 by 8 to find the common ratio, and I know that 12 and 8 are both divisible by 4, so I get 3 times 4 is 12 and 2 times 4 is 8, and this gives me 1 and 5/10. Okay, so this is my ratio when I'm dividing here. What about 18 over 12? So divided by 6, I again get 3 over 2, which is 1 and 5/10. And then 27 divided by 18 is also going to give me 9 times 3 is 27, 9 times 2 is 18. And so look, I get the common ratio of 1 and 5/10. Okay, so since I know that's the common ratio, the next thing that I'm going to do is I am going to multiply 27 here, 27 times 1 and 5/10, and I am going to get 40 and 5/10. So my next number is 40 and 5/10. So this is my 5th number. Okay, and then I'm going to have my 40 and 5/10. 40 and 5/10 times 1 and 5/10 is going to give me 60 and 7500. And then I'm going to take 60 and 7500 times 1 and 5/10, and I am going to get 91 and 125 thousandths. So these are the next 3 numbers on this list of this sequence, of the geometric sequence. I have 40 and 5/10, 60 and 7500, and 91 and 125 thousandths. So that's how I find the next 3 terms. You find the common ratio, and then you take that common ratio and you multiply it with each term to get the next 3 terms. All right, so let's look at the formula for the nth term of a geometric sequence. And that is written out like this over here. Okay, and so if I'm looking at this, the n is standing for the number. Let's say it's, are you trying to find the 16th term? Are you trying to find the 100th term? Are you trying to find the 12th term? So this is for that number that you are trying to find. Okay, A1 is nothing but the first number. This is my first number. Okay, and then R is, and you can write it like this. Okay, and R is my common ratio, and then the n is the number, whichever one that I'm trying to find. So same thing here. This is for that number too. Okay, so if it's the 16th number I'm trying to find, I'd put 16, the 16th term that I'm trying to find, I'd put 16 over there. If it's the 25th term I'm trying to find, that's the number that I'm going to put 25 over there. But this is the formula for the nth term of a geometric sequence. All right, so remember that n is the number, that the term that you're trying to find, and it is any positive integer. And please remember that r is not equal to 0, because anything times 0 would be 0, right? So that is why r is not equal to 0. So we are going to use this formula now, and it's saying that use an explicit formula to find the 11th term of each geometric sequence that is going to be provided now. So let's look at this one. And we are seeing that the first term of the sequence is 512. So I am now going to just use this formula over here. Okay. And I know that my first sequence is what? 512. Okay. So this is 512. I'm just going to start inputting so this is my A1. Okay, so now let's find what the common ratio is. So this is my first one, which is my A1. That is my first number in the sequence. Okay, and so now let's look at our common ratio. If I take 256 and I divide by 512, I'm going to get 1/2. If I take 128 and I divide by 256, I'm getting 1/2. If I take 64 and I divide by 128, I'm getting 1/2. So this 1/2 is my common ratio. And we are going to use this common ratio to find the 11th term. So we said my common ratio is 1/2. Right? And we are trying to find our 11th term. So we are going to write it out as to the nth term. So we are trying to find now what term? The 11th term, which is going to be, to find the 11th term, I am doing 512, 1/2 raised to the 11 minus 1. And what is 11 minus 1? I get 10. So here. So a to the 11th term, okay, is 512 1/2 raised to the 10th power. And then when I simplify this, I am going to get my 512, okay, and over 1 and 2 raised to the 10th power is 1024. And then I'm going to simplify, and I know this is 1 and this is 2, right? And so therefore, my answer is going to be 1/2. And that's how I find the 11th term. Okay? Let's go ahead and do another problem. And I'm going to take you to my whiteboard for this one. All right, so let's look at this question. It's saying find the nth term of a geometric sequence. And we're writing the equation for the nth term of the geometric sequence. And we have the values given to us. The first term is 729, second one is 243, third is 81, fourth is 27. So we are trying to find the 8th term. Okay, so I'm trying to find the 8th term. For my 8th term, my first term is 729. And let's first find the common ratio. So when I divide 243 by 729, I get 1/3. If I divide 81 by 243, I'm getting 1/3. If I divide 27 by 81, I'm getting 1/3. So this 1/3 is my common ratio that I am going to put in here. And then I have n, which is what? 8 minus 1. Okay? So then I am going to do 729 and I have 1/3 raised to the 7th power. Okay, and then when I do that, I have 729 29 times 1 over, because 1 times 1 times get 3 to the 7th power, which gives me 729 times. When I simplify this, I'm going to get 2187. Okay, and then when I simplify this, this is 1 and this is 3. So I actually get my 8th term as 1/3, and this is my answer in the geometric sequence. My 8th term is going to be 1/3. Okay, and that's how we calculate using our formula. All right, let's look at a word problem. Population. North Dakota's population is increasing more quickly than any other state's population. In 2011, the population was 685,242, and it has been increasing by an average of 2.5% each year. If this trend continues, determine the estimated population in 2030. So as I can see that an exponential growth is going on in this problem. Okay, so the population is growing exponentially. We can apply the equation for exponential growth, which is y is equal to a1 plus r and raised to the t power, right? That is my time. So, hope you can see it in the red. If not, here, this is my t on the top. Okay, so since it is increasing at a rate of 2.5%, okay, that population is being multiplied by, let's say this is okay, we're going to say 1 plus, what is this going to be? 0.025, because I have to write it as a decimal. And my constant ratio is just this portion is 1 and 25,000. Okay, so I've got the entire formula, but I do know that in the middle part, that is what my constant ratio is going to be. Okay, and we know that 685,242, this is my A1, that's my first term. And then my constant ratio is this, what I just calculated, which is my R. This is my R. Okay, and so once I have this, we're going to talk about the population in 2030. So from 2011 to 2030, that is my 20th term. So till here, that would be my 20th term in the sequence. Okay, because from 2011, I'm going to 2030. So in order to calculate this now, I am going to use the formula for the nth term, which is AN is equal to A1, and we have the constant ratio R, and then we have N minus 1. And so my A20th, for the 20th term, I have my first term, 685,242 times my constant ratio of 1 and 25,000, okay, raised to the 20th term minus 1. So that means this whole thing, what is 20 minus 1? I am going to get 19. When I calculate this part, I get 19. Okay, and that's my exponent. And so then when I use my calculator to simplify, I am going to end up with the 20th term is going to be 1,095,462. So this is my population, estimated population in 2030 in North Dakota will be this much. Okay, so that's how we calculate geometric sequence. All right, so anyways, that is what geometric sequence is all about. Just use the formula that I provided you for geometric sequence to find the nth term. You're finding the first term times the common ratio, which is always achieved by taking the two numbers which are next to each other and dividing the number in the front with the one behind to get that common ratio. Okay, and then of course the exponential power for this is n minus 1. So whichever term you're trying to find, for example in this it was the 11th one, I would do 11 minus 1. If it is the 25th one, I would do 25 minus 1. So that's how I just substitute those values in there. Okay, so once again, in geometric sequence, what are we doing? We are basically multiplying the term before with the same constant ratio to go to the next term. And that's what makes a geometric sequence different from arithmetic sequence, because in arithmetic we are having a common constant that we are adding. But in this case, geometric sequence, we are multiplying. Okay, so that concludes module 9.5. Have a fabulous day, everyone.